I think that if we want to really understand the behavior and the lives of whales, we actually have to listen. Their life actually happens underwater, and that's why sound is so important to them. They're using sound in the same way that we use our vision, but sound is also how they communicate with each other, and it's very, very important that they're able to hear each other, so they're able to learn from each other. They also use sound to find their prey, and they also use sound to make their way through their environment. So through science, we now have a much better understanding of how different vocal traditions are being passed on between northern resident families. So it's one thing to be able to listen to these recordings, and it really does touch the hearts of people, and that is very, very important, because if you want people to protect whales, then they have to feel something for these whales. The other importance of collecting all of this acoustic data is understanding there's another sound under the water, and it's boat noise. And we now know that that boat noise very well could be having an impact on their daily lives. And the best way to do that is by using hydrophones.
Sound travels underwater very efficiently compared to air, about 4.5 to 5 times as fast. We use hydrophones underwater to convert sound pressure levels to electrical signals, so we can pick up things like marine mammals and human-caused anthropogenic noise from boats or other industry activities. This is essentially what collects the sound, but there's an entire support infrastructure behind it in getting the sound from the ocean floor to the lab for processing and listening and sharing. Places like Orca Lab, where there are 8 hydrophones in the water right now, allow us to track marine mammals through the underwater territory and also understand the effects of shipping traffic and boat noise. There are a lot of considerations when choosing a spot for a hydrophone. It can be based on bathymetry or underwater features, and it can be based on historical significance of marine mammal activity or anthropogenic noise. Deploying the hydrophones takes a whole team. They sit on the seafloor at about 20 meters just off of shore, which is shallow enough that divers can still get to them for maintenance or replacement. What I love about working with the BC Hydrophone Network and Orca Lab is that I get to work directly with people to build tools to help researchers and conservationists study the natural world and really make a positive impact.
The strength behind this project Whale Sound is that it's a collaborative project. So you have First Nation communities and NGOs working together to better understand the impact of noise on whales. What's very unique is that we have the ability to compare areas that are very, very quiet underwater in regards to vessel noise and areas that are very, very noisy. So now we can research how whales react to an area that's quiet versus noisy, and we can use that data for mitigation purposes to create slowdown zones and a quiet ocean for whales along the coast of BC.